to start your new chapter, rational number, after first term examination. Okay, so before starting this rational number, I want to recall some point related to your numbers. Okay, so first point is a natural number. Natural numbers. Students, you know that about the natural numbers. The counting numbers such as 1, 2, 3. Counting numbers such as 1, 2, 3, 4 and so on are called natural numbers. Natural numbers are counting numbers 1, 2, 3 such as 1, 2, 3, 4 and so on are called natural numbers. Next one is a whole number. Whole numbers. All counting numbers means that natural number together with 0 are called whole number. Natural number together with 0. 0, 1, 2, 3, 4 and so on are called whole numbers. So for a natural number, 1 is the smallest natural number. For whole number, 0 is the smallest whole number. There is no biggest whole number and there is no biggest natural numbers. Okay. Next one is a integer. Integers. Okay, it is also very important, students. Integers. The negatives of a natural number. The negatives of a natural number. -3, -2, -1. Negatives of a natural number together with whole number. 0, 1, 2, 3, 4 and so on. Integers, you know about that. Integers together are negatives of natural numbers together with whole number are said to be a integers. So right side of a 0, that 1, 2, 3, 4, it is called a positive. It is called a positive integer. And the left side of a 0 is called a negative integers. Okay, and 0 is neither positive nor negative. Okay, next one is a fraction. Any things which we if you write in form of any number, the number of a form of p upon q. Any numbers which you will write in p upon q, in form of a p upon q, means that numerator upon denominator. First one is said to be upside, is known as a numerator, and downside it is known as a denominator. Any numbers, if it is written in form of a p upon q, where q not is equal to 0 and p and q are said to be whole number, are said to be whole numbers, then p upon q is equal to a fraction. It is said to be a fraction. Okay, so any numbers, if it is written in form of a p upon q, where q not is equal to 0 and p and q are said to be a whole numbers, then p upon q is said to be a fraction. Then after, like example, 4 upon 5, 3 upon 2, 6, 7 upon 8, okay, 0 upon 1, they are said to be a fractions. Okay, so after that I'm going to start your point rational number. Okay, a number that can be expressed in form of p upon q, a number that can be expressed in form of P upon Q, a number that can be expressed in form of P upon Q where P and Q are integers, where P and Q are integers, and Q not is equal to 0, and Q not is equal to 0 is called a rational number. Is called Q not is equal to 0 is called a rational number. Is called a rational number. A number that can be expressed in form of P upon Q where P and Q are integers and Q not is equal to 0 is called a rational number. A number that can be expressed in form of P upon Q, where P and Q are integers, and Q not is equal to 0 is called a rational number. It is the same as it is like a fraction, but here P and Q are integers, but in fraction it is a whole number. P and Q are whole numbers. Okay, and Q not is equal to 0 is called a rational number. For example, 4 upon 5. 4 and 5 are integers, minus 2 upon 3. Okay, 4 upon minus 5, minus 2 upon minus 3, 0 upon 1, and so on, etc. They are said to be a rational numbers. The number that can be expressed in form of P upon Q means numerator upon denominator, where P and Q, that numerator and denominator both are integers, and Q, that denominators not is equal to 0, are said to be a rational number, students. And these are the examples: 4 upon 5, minus 2 upon 3, 4 upon minus 5, minus 2 upon minus 3, and so on, 0 upon 1 also. But if it is like a 4 upon 0, when Q not is equal to 0, means if Q is a 0, then it is not a rational number. It is not a rational number. Okay, students. Then after, some important points related to the rational number. Note, that is the important point. Okay, every natural number is a rational number. First one is every natural number is a rational number. Very important point, students. Rational number. Every natural number is a rational number, like a 4. So 4 upon 1, it is also a rational number. 6 upon 1. If you write upon 1, there is no change in the number, but it changing to it's a form. It is a 4 upon 1 is a rational number. 4 is a natural number. So every natural number is a rational number. Second point is every whole number. Every whole number is a rational number, but converse may not be true. Okay, every whole number is a rational number. Okay, it is also same as it is any whole number you will take that it is upon 1, that is also a rational number. And 0 is also, it is a special type of a number. 0 upon 1, it is also a rational number. Okay, students. Every integer, third point is every integer is also a rational number. Okay, every integer is a rational number. Every integer is a rational number, students, like a minus 8. So minus 8 upon 1 plus 2. So you will write it 2 upon plus 2 upon 1. Then it is also every integer is a rational number, but converse may not be true. Okay. So, but you remember this point, every natural number is a rational number, every whole number is a rational number, every integer is a rational number, and every fraction is also a rational number. So there is a every fraction is a rational number, and every fourth point is every fraction is a rational number, students. Any fraction you will take, that is also be having a rational number. Next one is a decimal. Every decimal, that when every decimal means that if it is a recurring or terminated, means that there is a two types. Non-terminating is not representing a fraction or not representing a rational number, but the decimal which is terminated or recurring, they are also representing a rational number, like a 0.5 dot means 555 and so on. If you write this 555 and so on, if you change this one in form of a fraction, what you will get? You will get this 5 upon 9, means that 5 upon 9 is also a rational number. So every decimal which is terminating or recurring, they are also a rational number. Okay, so this is a important point, that is note, and it is given in your book. You can write these points in your copy with your proper definition and example, students. Now I'm going to talk about a positive and negative rational number. Here I'm going to talk about a positive and negative rational numbers. So very important and very easy. Positive means that if both numerator and denominator, means p and q, if both are positive, for a positive, I am talking about the positive. If both numerator and denominator are positive, have a plus sign, or both have a negative sign, they are said to be a positive rational number. Like 4 upon 5, there is no sign, means that it is a positive. Or minus 2 and minus 3, if both are negatives, its numerator and denominator both are in negative, then it is also said to be a positive rational number, because it is going to be cancelled out. Minus is cancelled out by minus, you will get this 2 upon 3. Okay, so positive rational number, if both numerator and denominator both are a positive sign, plus sign, then it is also a positive rational number. Or both have a negative sign, then it is also a positive integer. Okay, negative rational number. If negative rational number, if anyone, maybe either numerator or denominator, if it contains a negative sign, minus sign, they are said to be a negative rational number. This is a positive and here is a negative rational number. If anyone in that numerator and denominator, anyone contain a negative sign, then they are said to be a negative rational number. Like 4 upon 5, it is a positive. In this one, if anyone, suppose this minus 4 upon 5, then it is also a negative rational number. Or 4 upon minus 5, it is also a negative rational number. Okay, so a rational number is said to be a negative if either its numerator or its denominator contain a minus sign, and this positive if both numerator and denominator both contain positive sign or both contain negative sign, they are said to be a positive rational number. One special points related to this positive and negative rational number, that is what you will consider this one, 0 upon minus 1. It is a positive or negative, students? 0 upon minus 1. So because if you are getting this type of if denominators is a negative, students, so your aim is to convert it into a positive by multiplying negative sign, both numerator and denominator. If you are doing this one, you will get this minus. So 0 is neither positive nor negative. So 0 upon 1. So 0 upon 1 means that 0 is neither positive nor negative. So you will not consider as a positive, you will not consider as a negative. 0 upon minus 1 is the same as it is 0 upon 1, and it is equivalent to 0. 0 is neither positive nor negative rational number. It is a rational number which have no sign, not a positive nor a negative. Okay, so don't consider 0 upon minus 1 is a positive as a 0 upon 1 is a positive rational number, and negative 0 upon minus 1 is a negative rational number, because 0 is neither positive nor negative. Okay, students. So students, I am going to talk about some properties of a rational number. Properties of rational number. Properties of rational numbers. So very important, students. First point is for this. If any rational number p upon q is there, okay, so first property, if you multiply with any non-zero number in numerator and denominator, then you will get the another rational number which is same as it is like a p upon q. Okay, so if you multiply with any non-zero integer in p and q, both in numerator and denominator, you will get another rational number which is equivalent to p upon q. So p upon q is equal to p is multiplied by a non-zero integer n, and q is also multiplied by same non-zero integer n. Then we get this p n upon q n, which is equivalent to p by q. Both, suppose for example 2 upon 3. Okay, I am going to multiply with any non-zero integer. Okay, so I am going to multiply by 4. So 3 is also multiplied by 4. What you will get this 8 upon 12. Okay, so 4 2s are 8 and 4 3s are 12. 8 upon 12. There is a 12 parts in that it is represent 8, and there is a 3 parts in that it is represent 2. If you change into decimal, you can represent an equal portion, or in that fraction it is also represent an equal amount. Okay, so both are same. If you cancel out by 4, 4 2s are 8, 4 3s are 12, you will get this 2 upon 3. So it is very important property, students. If p and q is a rational number and n is any non-zero integer, and by multiplying both numerator and denominator, you will get the another rational number which is equivalent to the first rational number. By using this property, you will change the negative denominator as a positive denominator by multiplying with any negative numbers. Okay, so this property is helpful, very helpful for you students, and it is also useful to finding a equivalent rational number by multiplying any non-zero integer in a given rational number in numerator and denominator. Now the second one is and it is given in your book. You can use your book and write this property briefly in your copy. Okay, now the second property, same as it is. If you have taken a rational number p upon q, and you will divide this divide by any non-zero integer p upon q, and it is equal to p is also divided by m and q is also divided by m, then you will get another integer. Suppose if you are getting, by dividing, if you are getting it A upon B, which is equivalent to P by Q, which is equivalent to P by Q. Both are equivalent, means they are representing same proportion, same ratio. Okay, as I will show you with an example. Suppose here it is a 10 upon 30. Okay, 10 upon 30, and it is going to be divided by any same non-zero number. Suppose it is divided by 5. 10 is divided by 5 and 30 is also divided by 5. You will get another rational number, that is 10 is divided by 5, you will get this 2, and 30 is divided by 5, you will get this 6. Okay, so 2 upon 6 is the same as it is like a 10 upon 30. 2 upon 6 is the same as it is like a 10 upon 30. So this is also a very important to reduce. By dividing, you will get a equivalent rational number. Property 3. Okay, 2. This is based on a 2 rational number. If P upon Q and R upon S, there is a 2 rational number. Okay, and if they are equal, 2 rational numbers are said to be equal. 2 rational numbers are said to be equal if their cross product of their cross multiplication is equivalent. Okay, 2 rational number P upon Q and R upon S are equal. Then, if both are equal, P upon Q is equal to R upon S, then cross multiplication P into S is equal to Q into R. Very important students. P is multiplied by this one and Q is multiplied into R. So P into S is equal to Q into R, students. Very important. If 2 rational numbers are said to be equal, then their cross product is also equivalent. And if their cross product converse, if their cross product is equivalent, then they are said to be a equivalent or equal fraction. Okay, or equal rational number. Okay, so example 4 upon 5 and 12 upon 15. I have taken a 2 rational number, 4 upon 5 and 12 upon 15. Okay, they are said to be equal, are equal. So see that their cross products are equal or not. So first is multiplied into this one, 4 into 15, and this one is a 5 into 12. 4 into 15, what you will get this one, students? 4 into 15, 60, and 12 into 5, it is also 60. Both are equal, means that if 2 rational numbers are equal, then their cross product also equal, students. Or if their cross products are equal, then they are said to be a equivalent fraction. They are said to be a equal rational number also. Okay, now standard form of a rational number. Standard form of a rational number, very important, students, and very easy also. Standard form of a rational number. A rational number is said to be in standard form when its numerator and denominator have no common factor other than 1. Standard form of a rational number. A rational number is said to be in standard form if or when its numerator and denominator both have no factor as a common except 1. Means that if they have only 1 as a common factor, then they are said to be in standard form. Like for example, a rational number is said to be in again I am going to repeat this one. Rational number is said to be in a standard form when its numerator and denominator both have no common factor except 1. Okay, so like 4 upon 5. 4 and 5 both have a 1 as a common factor. So they are said to be in a standard form. Only 1 as a common factor. Common factor is 1. Common factor is 1. So they are said to be in standard form. They are said to be in standard form. Suppose 15 upon 18. They are said to be in standard form or not? Because what is the factor of 5? 3 and 5. And what is the factor of 1 into 3 into 5? Here is a 1 into 2 into 9 into 3 into 3, students. Okay. So in this one, 1 as a common and 3 is also common. So more than 1 means it is not in a standard form. If you cancel out this 3 is going to be cancelled out by this 3. You get this 5 upon 6. So 5 upon 6 is the standard form of a 15 upon 18. So by cancelling out with a common factor, how you will find this common factor? That is, you will find the SCF of both that numerator and denominator. Then by that SCF, if you divide this one, you will change it into a standard form or simplest form, or by cancel out both numerator and denominator with any non-zero. That is important point, that is property or important point. I have told you that by cancel out numerator and denominator with a same non-zero number. So 15 upon 18, this is also this is cancelled out by 3 and this is also cancelled out by 3. Okay, so 3 5s are 15 and 3 6 are 18, and then after it is not cancelled out by any other same number. It have only 1 as a common. So 5 upon 6 is in a standard form. So by dividing, you will change a given rational number into its simplest form. Okay. Now I'm going to solve. Hello students, I'm going to solve some example, and in next video I'm going to solve your problem of your first exercise of this chapter. Okay, so here I'm going to solve some examples. So first one is that example is to change into a simplest form or standard form. Your question is 126 upon 210. That is your question, to change it into a standard form. So very easy. There is a two way. First one is by dividing a same non-zero number, both numerator and denominator, you will change it into a standard. Now convert it into standard or simplest form. Standard form. Okay, so 126 upon 210, it is cancelled out by 2. So I am going to cancel out by 2. 2 5s are 2 6s are 12 and 2 3s are 6. 1 0 5. Then it is not cancelled out by 2 because this is an odd number, this is also, and it is again cancelled out by 3. 3 2s are 6, 3 1s are 3. Okay, and 3 3s are 9, 3 5s are 15. Okay, 21 upon 35, and it is cancelled out by, again it is cancelled out by 7. 7 3s are 21 and 7 5s are 35. You will get this 3 upon 5, and again it is not cancelled out by any other number. So 3 upon 5 is the standard or simplest form of 126 upon 210. So by this way you can find the factors of 126 and 210, and then you will cancel out the common factor. Then also you will get the same step. Second method is students, for this case 126 upon 210, find the SCF. So it is also by using SCF method, SCF highest common factor. Okay, so 126 is going to divide this 210. It is 1 times 4. 10 minus 2, 8. Cancel out. 126. Again it is 1 times. 84. 2. 4. Again it is 2 times. 84. So what is the SCF of? So SCF of 126 and 210 is equal to 42. 42 is the SCF of given 126 and 210. So by that SCF you will divide this 126 and 210. So 126 upon 210 is equal to 126 divided by 42 and 210 is divided by 42. If you divide this one, 42, 126, 3 times, 3 2 is 6 and 3 4 is 12. So you will get this here 3 and 210. If you divide this by 42 with 5 times, you will get this 210. So what you will get this, students? You also get this 3 upon 5. So this is by this way, by cancel out with any same non-zero number, you will cancel both numerator and denominator, and you can repeat this step until that when you will get 1 as a common factor, then that rational number is in a simplest form or in a standard form, students. Or by you finding the highest common factor, by that factor you will divide both numerator and denominator. You will change the given rational number into its standard form. So you will try to solve other examples of your book, okay, students, and a few other examples also given in your book. To find the equivalent rational number, it is also very easy to find the equivalent rational number of 4 upon 5. Find the two equivalent rational number of 4 upon 5. So by multiplying 2 in both numerator and denominator, you will get 8 upon 10. It is equivalent to this one. 4 upon 5 is multiplied by 3, both numerator and denominator. So 8 upon 10 and 12 upon 15. Both are equivalent to 4 upon 5. So by multiplying with any same non-zero number in numerator and denominator, you will change the given rational number into its equivalent rational number. Or by dividing any rational number, both numerator and denominator, you will change that rational number into its equivalent rational number, students. So I think by using this definition and important properties, you will solve the given example in your book. You will try to solve as a practice, students. In next video, I'm going to solve your exercise. I'm going to solve your question of your exercise, students. Okay. Thank you, students.